told you that modern construction technologies are not a step forward, but a huge step backward compared to what our ancestors knew how to do. We are used to thinking of concrete and steel as absolute symbols of progress, reliable, durable, designed to last for centuries. But you only need to open your eyes and look at the cracking facades of new buildings, crumbling bridges, and concrete boxes that need repair after only 30 years to realize that something is clearly wrong with this picture. Medieval stone walls have stood for 900 years, buffeted by winds, enduring cycles of frost, rain, fire, and even sieges. Castles, monasteries, towers, all of these have survived empires, wars, and human negligence. And in most cases, they did not require major repairs. Why is limestone, mined with primitive tools, stronger and more durable than modern concrete mixtures developed in laboratories? The secret lies in a technology that is almost forgotten today: the ability to work with the material rather than against it. Medieval craftsmen created what was called living stone, a structure that did not harden once and for all, but continued to strengthen over the years. Watch the video to the end to find out exactly how this amazing living stone technology worked, why modern engineers still cannot replicate its properties, and how simple medieval walls managed to surpass the most advanced materials of the 20th and 21st centuries in terms of strength. Are you ready to learn the truth about how medieval castles actually worked? There is a persistent myth that the stone buildings of the past were always unbearably cold and damp. We tend to think that thick walls were needed solely for protection against enemy raids and siege weapons. However, ancient architects approached the task of survival in a much more complex and wise manner. The walls of castles and houses served a function that modern builders often forget in their pursuit of speed. Stone has a unique physical property called thermal inertia, or heat capacity. Unlike modern thin panels, stone does not simply insulate a room from the street, it works like a battery. During a long summer day, massive walls absorb the sun's heat, slowly warming up to the very center. When a cool night comes, the stone begins to release the accumulated heat back into the room. This created a natural thermoregulation cycle that did not require electricity or complex equipment. The thickness of the walls, sometimes reaching 2 or 3 meters, was carefully calculated for this very process. The heat wave passed through such a thickness of stone with a certain time delay. This meant that the midday heat only reached the interior rooms at night, when it was needed, and the coolness of the night penetrated inside by the middle of the hot day, acting as a natural air conditioner. Ancient craftsmen intuitively understood the physics of these processes better than many modern designers. Modern concrete, on the contrary, has a completely different structure and thermal conductivity. It heats up quickly and cools down just as quickly without creating a comfortable microclimate without additional insulation. We are forced to cover our homes with layers of foam and cotton wool to compensate for the shortcomings of the material. A medieval wall was a self-sufficient system that worked in harmony with the environment. It was not just a pile of stones, but a complex engineering organism. It is important to understand that comfort in the Middle Ages was a matter of life and death, not just convenience. In harsh winters, the ability of a house to retain heat determined whether a family would survive until spring. A stone hearth heated the interior masonry, turning the entire house into a huge oven. The walls absorbed the heat from the fire and radiated it gently and evenly for many hours. Such radiant heat is much more pleasant and beneficial to humans than the dry air of modern radiators. Natural stone has a porous structure filled with air, which also improves its thermal properties. Different types of stone were used for different parts of the building, depending on their density. Denser granite was used for the foundation to cut off the cold from the ground. Lighter limestone or sandstone was used for the walls to retain precious heat. This skillful selection of materials is a lost art, replaced today by standardized concrete. Builders of the past could not afford to make mistakes, as they did not have central heating. They relied on the mass of the material and its natural properties to create a livable space.
Wonderful.
A modern house without electricity and gas would freeze in a matter of hours. A medieval stone house could maintain a positive temperature for days on end, solely due to the heat accumulated in its walls. This was true energy efficiency, achieved without synthetic materials.
As the morning mist,
We are used to looking at ruins and seeing only cold gray stones. But when these buildings were intact, they were warm and cozy fortresses. It was the understanding of the properties of stone that allowed people to survive the harshest periods of history. It was architecture created for people, not for square footage reports. We are very interested in hearing your point of view. What do you think? Could modern architects build something similar without using modern insulation materials?
One must
Write about it in the comments.
architecture.
Don't forget to subscribe to the channel so you don't miss new analyses of historical technologies.
Architects achieve the same effect without using.
Want to know a secret that will change your perception of reliability? The main reason for the durability of medieval walls lies not in the stone itself, but in what binds it together. We are used to cement, which hardens into stone and becomes a solid monolith. But ancient builders used a completely different binding material, lime mortar. This material had amazing properties that seem almost magical today. Unlike modern Portland cement, lime mortar remains plastic for centuries. It does not try to resist the movement of stones, but works with them. When a building settles or the ground beneath it shifts, hard concrete cracks. A lime joint in a medieval wall can deform without breaking. This allows the building to breathe and move while maintaining its structural integrity. But the most remarkable property of lime is its ability to self-repair. If a microcrack appeared in the masonry, rainwater inevitably got into it. The water dissolved the lime particles inside the joint, turning them into a saturated solution. Then, as the water evaporated and came into contact with the air, the lime recrystallized. The crack literally healed itself, filling with new stone material. This process is called carbonation, and it can last for hundreds of years. The building constantly repairs itself without human intervention. Modern concrete completely lacks this ability. As soon as a crack appears in concrete, it becomes the beginning of the end. Water gets inside, freezes, expands, and breaks the material from the inside. Ancient craftsmen knew that hardness is not always synonymous with strength. The excessive hardness of modern cement makes it fragile in the face of time and the elements. The softness and pliability of lime mortar, on the contrary, ensured its durability. This is the philosophy of Aikido in construction. Do not resist force, but extinguish it. Preparing the right lime mortar was a real art that took time. Lime was slaked in special pits for years before being put to use. The longer the lime was aged, the more plastic and higher quality the mortar turned out to be. Today, no one can afford to wait 3 years just to start laying bricks. The speed of modern construction has killed the quality of the binding material. In addition, lime is a natural antiseptic that prevents the appearance of mold. No fungi that could destroy the stone or harm the health of the inhabitants grew in the thickness of the wall. This created a healthy microclimate inside the room, which is so lacking in concrete boxes. The walls remained dry and clean for centuries. Interestingly, lime mortar only becomes stronger over time. It continues to harden by absorbing carbon dioxide from the air, effectively turning back into limestone. After 500 years, the joint becomes as strong as the stone itself. Modern concrete reaches its rated strength in 28 days and then begins to slowly degrade. We traded an eternal material for a quick one, winning in time but losing in eternity. The secret of living mortar is a lesson in humility before nature. The ancients did not try to defeat time, they negotiated with it. Perhaps that is why their towers still stand, while our garages are falling apart. But there is another nuance concerning modern reinforcement that you may not be aware of. What if I showed you a time machine frozen in stone? Medieval architecture is unique in that it worked exclusively on compression. Stone blocks were laid so that the building's own weight would not destroy it, but rather strengthen every part of the structure. Stone does not like sudden loads and cannot withstand tension, so craftsmen avoided anything that could lead to internal cracks. They created a system where all forces were directed downward, and the more massive the building became, the more stable it stood. Look at the shape of the vaults, arches, and domes in ancient cathedrals and castles. They did not arise from a desire for beauty, although over time they became its embodiment. Their curved shape was a precise engineering answer to the question of how to make heavy stone support huge floors. The load was transferred along the curve of the arch to the walls, which took on this weight without resistance. The entire structure seemed to breathe with the earth, adapting to the slightest movements that today would cause cracks. The weight of the heavy ceiling was distributed gradually, as if by steps, moving from the top of the arch to the supports. The buttresses, protruding outward, absorbed the excess pressure and transferred it to the ground. Thanks to this, gravity, which modern engineers often perceive as a threat, became an ally of the builders of the past. The stones sought to move downward, and the building only became stronger, like the roots of a tree going deeper into the soil. The walls at the base of medieval buildings could be several meters thick. This was necessary to create a low center of gravity and enormous stability. Such massiveness turned a house or tower into a kind of artificial rock, comparable only to natural formations. The higher the builder climbed, the more he reduced the thickness of the walls, achieving a smooth taper. This taper allowed the building to survive even strong earthquakes, as the center of gravity remained at the bottom. Modern skyscrapers are thin needles that have to fight the wind and vibrations using complex metal frames. Medieval towers, on the contrary, stood like immovable monoliths. They did not try to reach for the heavens, they sought to become part of the earth. This approach made them extremely stable and independent of external forces. They did not need electrical equipment, sensors, or moving joints to remain intact for centuries. The absence of metal beams and floors, which today would seem to be a disadvantage, was actually an advantage. Metal and stone react differently to temperature and humidity. When heated, steel expands faster than stone, causing stress. In medieval buildings, there was no such conflict because the entire structure was monolithic and reacted to nature in the same way that a single living organism reacts. There was simply no difference in the behavior of the materials. This prevented walls from developing dangerous microcracks, which often appear in modern buildings after just a few years of use. Stone could slowly move with the ground without breaking or losing its shape. It was part of the natural cycle, rather than a material that needed to be constantly monitored and maintained. A medieval house could stand for centuries without a single repair if it was built correctly. The windows in such buildings were made narrow and deep. They limited the flow of light but preserved the strength of the walls. Each opening was seen as an intrusion into the monolith, so craftsmen tried to minimize its destructive impact. They created complex slopes to better distribute light inside while maintaining maximum stability of the masonry. Even a small window was thought out to the smallest detail. The geometry of the rooms also played a huge role. Vaulted ceilings allowed air to circulate freely, which helped maintain a stable temperature and prevented moisture buildup. The house became healthier, and the walls suffered less from mold and humidity fluctuations. Natural forces worked with the builders, not against them, and thanks to this, the buildings lasted longer. Warm air rose along the curved lines of the vault, distributing evenly throughout the room. This created a mild climate inside and helped avoid extreme temperature fluctuations. Unlike modern concrete floors, which often create cold zones, stone arches acted as natural regulators. Architecture became an extension of nature rather than an attempt to outsmart it.
Contrasting with the concrete floor.
Each stone was selected by hand by a master craftsman. He did not just take the first block he came across, but looked for one that would fit perfectly. The stones had to fit together not only with mortar, but also thanks to their shape. They were hewn so that they literally clung to each other, creating a structural mesh that could not be destroyed with a single blow. This made the masonry alive and durable. This bandaging of the joints turned the wall into a single organism. If one part was under stress, the neighboring parts helped it to maintain its shape. It resembled a giant puzzle that was held together not by cement, but by the skill of a person who knew how to connect shapes. Even centuries later, such walls remain surprisingly strong because they are built according to principles that never go out of date. It is surprising that most of these engineering solutions appeared not thanks to science, but thanks to experience. The masters studied their mistakes and passed on their knowledge to their students. They knew how an arch would behave under the weight of snow, how a wall would sound in the wind, how stone would react to winter. This knowledge was not recorded in textbooks. It lived in the hands and eyes of the people who built for future generations. Errors in calculations could cost lives. Therefore, every successful building became proof of the correct method, and every destruction became a lesson. What we see today is the result of natural selection in architecture. Only the most reliable solutions survived. Everything weak disappeared, leaving us with a collection of forms honed over centuries.
Contributed to refining architectural techniques.
We are used to building quickly and high, without thinking about how long a house will last after we are gone. We believe in technology and forget about the laws of physics, which people in the past respected as something immutable. They built as if they were going to leave their mark forever. And in a sense, they succeeded because their buildings still stand today, having survived wars, disasters, and time. Want to learn a secret that will change your life and your attitude towards your own home? Like this video, and we will continue to reveal the secrets of ancient builders. And be sure to subscribe to the channel so you don't miss any new videos. Are you ready for the shocking truth about modern homes? The main reason why modern concrete does not last longer than 100 years is hidden deep inside it. It is the steel reinforcement that is laid in to give the concrete tensile strength. 20th century engineers decided that combining steel and concrete was a brilliant idea that would allow for cheap and fast construction. But they planted a time bomb in the foundation of our civilization. The problem is that steel inevitably rusts. Even deep inside a concrete block, the metal eventually comes into contact with moisture and oxygen. Concrete has a porous structure, and microscopic amounts of water seep into the steel rod. The chemical reaction of oxidation triggers an irreversible process of destruction from within. When steel rusts, it increases in volume several times over. Rust begins to press on the concrete from the inside with tremendous force. This pressure breaks the concrete block, creating cracks and chips. Engineers call this process concrete cancer, and there is no cure for it. Medieval walls do not contain any foreign metal elements. They are made of pure stone or brick held together with mortar. There is nothing to rust and nothing to expand, destroying the masonry. The homogeneity of the material is the key to its peaceful existence over the millennia. Stone ages gracefully, simply weathering on the outside rather than exploding from the inside. Modern builders try to combat this by using galvanized steel or special additives. But this only delays the inevitable end, which will come in 50 or 80 years. The protective layer of concrete carbonizes over time and loses its protective properties. Once the alkaline environment of the concrete is neutralized, steel corrosion becomes a matter of time. This is why we see balconies crumbling on Khrushchev-era apartment buildings and bridges built just half a century ago cracking. A structure that relies on two conflicting materials is doomed to a short life. We have become hostages to a technology that requires constant costly repairs or demolition. In the Middle Ages, metal brackets were used, but they were placed on the outside or filled with lead. Stone always remained the main load-bearing element, working independently. If the metal tie rusted, it could be replaced without destroying the wall. In reinforced concrete, it is impossible to replace the reinforcement without destroying the building itself. This is a fundamental mistake in modern construction philosophy. We create non-demountable, disposable structures. We build houses in the same way we make plastic cups, use and throw away. The ancients built so that their grandchildren could use the house in the same way as their grandfathers. The lack of reinforcement limited the ancients in terms of form and height, but gave their creations immortality. They sacrificed speed and flexibility for reliability. We chose the opposite path, and now we are paying for it with constant reconstruction of cities. But if steel kills concrete from within, what makes stone so resistant to the external environment? Why do you think old basements are often drier than modern parking garages? Moisture exchange is the invisible process that determines the health of any building. We often turn modern houses into airtight thermoses, sealing them with films and impermeable insulation. The moisture that inevitably forms inside from people breathing and cooking has no way out. It accumulates in the walls, causing rot, mold, and material deterioration. Medieval stone walls had a unique vapor-permeable property. They work like a membrane, allowing excess moisture to escape to the outside, but not letting water in. Lime mortar and porous stone absorbed moisture from the air when there was an excess and released it when there was a shortage. The walls literally breathed, regulating the humidity in the room naturally. The absence of waterproofing films was compensated for by the thickness of the wall and the quality of the materials. Water during slanting rain could wet the outer layer of the stone, but never penetrated through it. The wind and sun quickly dried the surface, and the wall was ready to protect again. It was a constant, dynamic process of interaction with the elements. Modern concrete itself does not allow vapor to pass through well, and when vinyl wallpaper and insulation are used, the wall becomes impervious. Moisture is trapped inside the structure, freezes in winter, and tears the material. It is frozen water in the pores that is the main destroyer of any stone. But in lime mortar, the pores are large and open, so the water has room to expand when it freezes. Ancient craftsmen intuitively understood the importance of capillary water movement. They often made the base from granite or other dense stone that does not draw water from the ground. Above it was lighter and more breathable limestone. This cut off ground moisture but allowed the walls to evaporate what came with the rain. The rooms of those years did not have black mold, which is the scourge of modern new buildings. The high alkalinity of lime killed any fungal spores at the root. The walls remained healthy for centuries without any chemicals. This ensured the preservation not only of the building, but also of the wooden floors and furniture inside. We fight water by creating barriers that sooner or later leak. The ancients did not fight water, but managed it, allowing it to pass through and evaporate. This approach proved to be much more far-sighted in the long term. The walls did not accumulate fatigue from cycles of wetting and drying. Even the shape of roofs and eaves was designed to protect the walls from water. Far-reaching slopes diverted rainwater away from the foundation. Every architectural detail had a practical purpose in terms of moisture removal. Beauty was merely a consequence of functionality. Today we try to solve humidity problems with complex ventilation systems and dehumidifiers. But as soon as the electricity is turned off, a modern house begins to suffocate and become damp. A medieval castle continues to regulate its microclimate, even when abandoned. Natural materials always strive for balance with the environment. Artificial materials try to isolate themselves from it, and in this war, they always lose. What large companies hide is that the standardization of materials is a path to degradation. Modern concrete is the same in the desert as it is in the north. It is a standard mixture. Medieval builders approached the choice of materials with the care of jewelers. They used local stone not only for logistical reasons, but because it had already been tested by the climate. Stone that had lain in this land for millions of years had already proven its resistance to local frosts and winds. Craftsmen went to quarries and observed how the rock behaved in natural conditions. They chose layers without cracks, with the correct stratification. It was a natural selection of material, where nature itself weeded out defects. There was an important rule: to lay the stone in the wall in the same way as it lay in the quarry. The layers of sedimentary rock must be horizontal so that the load presses perpendicularly on the layers. If the stone is placed on edge, it will begin to delaminate and flake off after a couple of decades. Today's decorators often disregard this rule in favor of a beautiful pattern. Stone was quarried according to the seasons so as not to damage the internal structure of the material. Stone quarried in winter was considered unsuitable as it could contain frozen water. Blocks were quarried in spring and left to rest under a canopy all summer. Only after the mountain moisture had left the stone was it put to use. Different types of stone were combined to achieve the ideal balance of strength and thermal insulation. Corners and window openings were reinforced with hewn hard stone. The main body of the wall was filled with irregularly shaped rubble stone, which created many air pockets. This improved heat retention without losing load-bearing capacity. Understanding geology was part of a mason's craft. They knew which stones were vulnerable to fire and which to water, which could be used in the foundation and which only under the roof. This knowledge was gained through centuries of observing how their ancestors' buildings aged. A mistake in choosing stone could only be washed away by rain and time. In modern construction, we rely on quality certificates and laboratory tests. But accelerated tests in a chamber cannot simulate 300 years of real temperature fluctuations. Only natural materials can withstand the real test of time. Even the mortar was selected for a specific type of stone. Mortar that was too strong could break soft sandstone, so the composition of the mixture was always adjusted. It was a delicate balancing act to ensure that the entire system worked as a single organism. We replaced in-depth knowledge of the material with standardization and GOSTs. This simplified the process, but deprived the buildings of individual protection against the local environment. Each medieval house was a unique response to the challenges of a specific location. Did you know that the very concept of time for builders of the past was different from ours? Do you think modern people are ready to build a house that only their grandchildren will finish? The modern world is obsessed with speed. We want everything right away, instantly, as if time were our enemy rather than our ally. We want a turnkey house in one season, as if construction were not a dialogue with the material, but a race against the stopwatch. To a medieval person, such haste would seem like madness, a whim of people who have lost their sense of proportion. In their view, any serious building must go through a slow process of realization, almost like the growth of a human being. It cannot be accelerated without consequences. The walls grew not because the craftsmen were lazy, but because they listened to the material, understood that the stone needed time to find its place in the masonry, to settle into the overall structure. Usually only a meter or a meter and a half of walls were raised in one season, and that was enough for the building to live according to natural laws. In the fall, construction was halted, covering the fresh masonry with straw, boards, or temporary roofs to protect it from rain and sudden cold. Over the winter, the mortar set, the stones intertwined with each other, and the foundation slowly adjusted to the characteristics of the soil. With the arrival of spring, the craftsmen carefully inspected their work. If a crack appeared, if a block shifted slightly, if the soil subsided, it was noticed immediately. The mistake became obvious and could be corrected before it grew into a problem. This rhythm prevented the catastrophic distortions that modern houses sometimes suffer from after completion. Medieval buildings settled over time, layer by layer, finding their balance. Today, we build high-rise buildings in a matter of months, and they continue to live their painful lives with their residents, cracking, vibrating, pulling at the walls as if trying to make up for the missed stage of natural settling. We try to cheat physics with chemical accelerators, polymers, and miracle resins, but nature cannot be forced to move faster than it is capable of. The lime mortar that had been used for centuries did not like haste. It slowly gained strength, and the craftsmen respected that. No one rushed to meet deadlines, open the facility, or welcome the bosses. The main criterion was quality, because the builder was not working for an abstract client, but for his neighbors, his family, his clan. He understood that people would live in this house, pass it on to their children, and that any shoddy work would be a disgrace that would be remembered. Reputation was far more important than money. The duration of the work was also a safeguard. If the foundation was weak, if the corner was washed away, if the water rose higher than usual, it was noticed early on. It was possible to dig deeper, reinforce, rebuild, rather than pretend that it will do. Modern monolithic construction rarely offers such a luxury. If a mistake is made in the zero cycle, it will haunt the entire house until the very end, and it is often impossible to correct it. Medieval slowness was a form of wisdom, not technical limitation. From an economic point of view, this approach was also justified. Construction was carried out as funds were accumulated, rather than on the principle of, let's take out a loan and figure it out later. The family built the walls as high as the year allowed, and when they had more money, they added the next tier. The house grew along with the people, along with their capabilities, without becoming an unbearable burden. This created an amazing harmony between human life and the life of the building. The slow pace also made it possible to rely on small teams of true craftsmen. These were people who knew stone as well as a farmer knows his soil. They did not need hundreds of apprentices. Each stone passed through the hands of a person who understood where to place it, in which position it would work better than in another. The human factor was not a threat, but the basis of quality. We have lost the culture of anticipation. We think that a house that is not built in one summer is a failure. But strangely enough, buildings that are erected quickly become obsolete just as quickly, require repairs, and crumble under their own weight. The speed we are so proud of destroys quality at the molecular level because it deprives materials of the most important thing: time to adjust to each other. And ultimately, it was this slow maturation that made buildings eternal. The slower you go, the longer the house stands. And perhaps this old truth hides the most important lesson in construction, one that we have almost lost today. Heating in a medieval house was not a separate engineering system of pipes and radiators. The hearth and chimney were an integral part of the building's load-bearing structure. Huge fireplaces and stoves were built into massive interior walls, turning them into giant radiators. This solution solved several survival problems at once. When the hearth was burning, it heated not only the air in the room, but also the tons of stone around it. Chimneys were laid inside the walls to extract maximum heat from the smoke before it escaped into the flue. The wall heated up and continued to radiate heat throughout the night, even after the fire had died down. The massive stone chimney running through the center of the house also served as a support for the floors. It was the warm core of the building around which life revolved. The bedrooms and living quarters were located around this warm axis. Cold areas and storage rooms were moved to the outer walls, creating a buffer zone. Constant heating of the walls from the inside prevented condensation and dampness in the masonry. The stone always remained dry, which is critical for its durability and thermal insulation properties. A dry wall retains heat much better than a damp one. It was active protection of the structure with heat. The draft in the huge fireplaces provided powerful ventilation for the rooms. The air in the castle was constantly renewed, sucked into the firebox and escaping through the chimney. This rid the rooms of stagnant air, odors, and excessive humidity. The house was constantly ventilated without drafts, as the air flowed in through the cracks and out through the chimney. Ash from fireplaces was used to make lye and that very same lime mortar. The cycle was complete. The products of combustion helped to maintain and repair the house. Nothing was thrown away. Everything was used to sustain life and daily existence. Compare this to modern radiators, which only heat the air under the window. Our walls remain cold, which leads to dew point inside the structure. We heat the air while they heated the structure of the house. This is a fundamentally different philosophy of heat. Of course, the efficiency of an open fireplace was low by modern standards, but in combination with the heat capacity of the walls and the availability of firewood, this system was reliable and autonomous. It could not break down, leak, or be shut off for non-payment. As long as the fire burned, the house lived. The hearth was not just a place for cooking. It was the engine that drove all the life support processes of the building. The dryness of the walls, the freshness of the air, and the lives of the inhabitants depended on it. Ancient engineers did not separate architecture and heating. For them, it was a single entity, fused in stone.
Where moisture and mold can deteriorate.
One of the main advantages of stone masonry was its complete maintainability. A medieval building could be repaired indefinitely by replacing individual elements, like parts in a construction set. If a stone was weathered or cracked, it could be removed and replaced with a new one without demolishing the entire wall. This made the life cycle of a building virtually endless. In modern concrete, repair is practically impossible. If a concrete panel cracks, it cannot be glued back together with the same strength. The crack can only be cosmetically filled, but the structural integrity has already been compromised. Modern houses are easier to demolish and rebuild than to renovate. This approach shaped the owner's psychology as custodians. They understood that a house requires care, but that this care guarantees its eternal service. Modern people treat housing as a consumer good with a warranty period. We wait until the house is in disrepair to move to a new one. The availability of materials for repairs was absolute. Stone, sand, and lime were everywhere. There was no need to order complex polymers or factory parts. Repairs could be carried out by a local mason with a minimum set of tools. Independence from complex technologies was a guarantee of safety. Repairability also meant that operational errors were not fatal. Even if a house stood abandoned and roofless for half a century, its walls usually remained strong. It was enough to cover them with a new roof, and the house came back to life. A modern house without heating and a roof turns to dust in 5 years. We have created disposable architecture for disposable lives. The Middle Ages created eternal architecture for successive generations. The ability to repair is what distinguishes a reliable thing from rubbish. Every stone in an old wall is a testament to the fact that care and labor can prolong the life of an inanimate object indefinitely. The answer to why we no longer build for centuries lies not in technology, but in economics. The medieval method of construction was incredibly labor-intensive and required a huge amount of human time, which is too expensive in the modern world. Every detail was made by hand, every stone was processed, and the masonry itself required long pauses to gain strength. This approach does not fit into the rhythm of an era where money must be returned as quickly as possible, and deadlines determine the success of almost any project. For people living in a world of investments, loans, and the constant pursuit of profit, the idea of building walls designed to last forever seems like an almost pointless luxury. Stone, which for centuries was considered the foundation of strength, has turned out to be an inconvenient material in the era of global logistics. It is difficult to extract, difficult to transport, and every extra ton translates into additional costs. Concrete, on the other hand, can be prepared directly on site by mixing imported cement with water and local sand. This makes it an incredibly convenient and cheap material, even if it loses out in terms of durability. Modern construction is focused on speed of delivery and ease of installation, rather than on creating monuments that can survive for centuries. Logistics dictates its own rules, and there is not much room for quality in them. Another important factor is the loss of craftsmanship. It takes almost half a lifetime to train a master mason who understands the material as well as a musician understands their instrument. Such craftsmen were rare in past centuries, and today they have almost disappeared. They have been replaced by a workforce capable of quickly mastering simple operations such as tying rebar or pouring concrete. We have exchanged living experience and subtle knowledge of the material for standardized technologies in which speed is more important than artistry. Where once there was a person, today there is formwork and a team working according to instructions. The requirements we place on housing have also changed. People want spacious rooms, open floor plans, huge windows, and lightness in everything from the interior to the exterior of the house. Stone lives by different rules. It is heavy, requires massive walls and small spans, and loves semi-shade and thickness. It is difficult for modern people to accept that the beauty of a stone house always goes hand in hand with limitations. Comfort has become more important than durability, and architecture has adapted to this new philosophy. In addition, we ourselves have become more mobile than ever before. People move in search of work, climate, or new opportunities, and few people mentally associate themselves with one home for life. And if the owner does not intend to pass the house on to their children and grandchildren, why invest in such a long-term prospect? Real estate has become a commodity, an investment tool, rather than a family heirloom. A house is no longer a family stronghold, but a convenient box that can be sold, rented out, or exchanged for a better one. But today, observing how quickly mid-20th century neighborhoods are becoming obsolete, we are beginning to think about the consequences. Houses built to last for several decades are falling apart prematurely, and the problem of what to do with huge amounts of concrete debris is becoming increasingly acute. After demolition, a stone building turns into a pile of natural material that can once again become part of the earth. Concrete, on the other hand, leaves behind toxic dust, pieces of rusty rebar, and a mark that nature will not be able to heal for a long time. We have not yet found the perfect way to deal with this legacy. There is hope that in the future, we will be able to get closer to what the ancients did intuitively. Perhaps materials will appear that are similar in properties to natural stone, but are easy to work with. Printing technologies are already being developed that allow the creation of monolithic walls from geopolymer mixtures that are more durable than conventional concrete. But even so, the philosophy of building for centuries is unlikely to make a mass comeback. This would require not only a change in technology, but also a change in the very way of thinking, which is completely different today. Time flows too quickly, and people think too short-term to invest in centuries. Ancient builders did not possess magical knowledge. They simply lived in a different world, where every stone could become part of history, and every house was a continuation of the family line. Their goal was not convenience or economy, but survival and the mark they would leave behind. We live with different goals, and they shape a different architecture. Each era creates houses that resemble itself, and there is nothing surprising about that. But when you walk past an ancient fortress wall or cathedral, try to stop for at least a minute. Place your palm on the stone and feel the quiet warmth it has stored over the centuries. It is not just the warmth of the sun. It is the warmth of the hands of people who knew how to turn ordinary stone into eternity. Their labor is hidden in every unevenness of the masonry, and it has not disappeared. It waits patiently for its moment, reminding us that in a world of speed and constant change, durability still has a voice, and perhaps one day we will listen to it again. The history of the confrontation between stone and concrete is not just a dispute about building materials, it is a dispute between two philosophies. One says, be flexible, be adaptable, and you will live forever. The other says, be firm, conquer nature, and you will get results right now. We chose the second path and got comfortable, bright, warm houses that, alas, will not even outlive our grandchildren. Ancient walls continue to stand, reminding us that the simplest solutions are often the most ingenious. Perhaps we should stop looking down on history and admit that in the race for progress, we have lost something very important, something that allowed us to create things that time cannot destroy. Do you think modern people should return to using natural materials, even if it is more expensive and takes longer? Or are concrete boxes an inevitable price to pay for affordable housing for billions of people? Write your opinion in the comments, suggest topics for future investigations, and don't forget to subscribe to the channel. There are still many secrets ahead of us to uncover.